Okay, good morning. What we are going to do, we are going to take some topics on chapter 5. Okay, so we are going to introduce some special functions. Okay, start with the natural log, exponential function, and the inverse trigonometric function. So this is going to be what we are going to do, and we hope to finish it this week. So we are going to test that on quiz 4, and they are going to be given to you on the final. Okay, so your final mostly will cover the problem from test 3 and the quiz 4. Okay, so let's do it. It's going to be interesting function. There are many applications. Maybe in future these are going to be the only function that you are going to know you are going to use. Okay, so let me go to my notebook and start talking about this. In some other calculus book, they talk about these functions together with the other topics. But in your book, they usually cover it at the end. Maybe, it's not bad because you are going to see them mostly in calculus 2, okay? So you get something like 6 questions from these topics that I'm going to talk about it on the final. Okay, so there you are. Happy Monday. Today is Monday. Okay, Monday, 7/24. So we're going to take chapter 5 and 5.1. We're going to talk about the natural log function. Okay, what is the natural? It's very popular function in application problems. Okay, natural logarithmic function. There are different ways to define this function. You already got this function in your algebra course, but the way we are going to introduce it is a little bit different. But, that's to show you the nature of the calculus. So don't be surprised and be patient. Then we get to the definition that you usually get used to it from college algebra. So remember the integral function that we talk about it. I told you that sometimes a continuous function would be given to you. You want to integrate it. But it's not going to be the case that you'll be able to find it by looking for the antiderivative. That gives you the integral function. So the way we are going to introduce this function in calculus is using those type of ideas. Okay, so this is it. The natural, the notation first. The natural. So the natural log function. Logarithmic function. Okay, function is denoted. The notation that we're going to use is going to be denoted by this is the notation by y equal to ln of x. Okay, ln stands for the natural log. Ln of x and is defined by, and is going to be defined by, this is the way we're going to define it at this level of calculus, okay? The definition is going to be like the integral function. So it's going to be ln of x is going to be a function that's defined by this integral from 1 to x, okay, 1 to x, 1 over t dt. Okay, 1 over t dt. Of course, since it's 1 to x, so this means x must be greater than or equal to 1. Okay, this is an integral function. We already defined it. Since 1 over t is continuous for x greater than or equal to 1, because you know that 1 over t is going to be undefined when t is 0. But since we start with the 1, so we are safe. This function is continuous. So since this function is continuous, so this integral does exist. But remember previously, if you move this one up, that gives you t to the negative 1. So we cannot use the power rule to find it, because t to the negative 1, if you add 1 to the power, that gives you t to the 0 divided by 0, which is not possible. That's why this function would take care of that, okay, that the difficulty, that special case that we did have for the power rule. Okay, so from the geometry point of view, if you want to look at it, this is what we have. If you imagine the graph of 1 over t, okay, 1 over t, if you put a t equal to, okay, t equal to 1, we get the 1. So this is going to be 1. For example, this is also 1 for the, and then the 1 over t, you know that it's going to be a decreasing function. And if we graph it, it's going to be almost this function, okay? This is going to be the function of y equal to, okay, it's going to be y equal to the 1 over t. It's decreasing function, and y equal to the 0 is going to be the asymptote of this function. As you can see, it's going down. Now, what is going to be this 1 to x that we think about it? So this is starting from the 0. This function is, of course, is not going to be defined at 0. When t goes to 0, that would be infinity. So as you can see, this will tell you that this is the starting point, which is going to be 1. Okay, this is 1. So if you want to find the value of this function at, okay, at any number, so we can pick the x here. You see if this is going to be your x. So this integral is going to be area under the curve. So this portion over here, you see this portion? This portion over here is going to be your ln. Okay, this is going to be ln x. Okay, so it's going to be kind of area under the curve, and we already defined the area under the curve. So we are familiar with to get these numbers. Okay, and there are going to be a number of terms that we can see it from here. Okay, so the terms that we have to introduce over here is the fact that from the definition of the integral function, you see notes that the result was remember, if you put x equal to 1, that gives you ln of 1. ln of 1 would be integral from 1 to 1. Okay, 1 to 1, 1 over t dt. And we already talked about it. Integral from 1 to 1 is equal to the 0. Because in order to get the integral, you have to move from 1 to somewhere else. Okay, it's a 1, 1, so that gives us 0. So that would be our first observation of this new function. So the first observation is going to be ln of 1, okay, is going to be equal to the 0. Okay, this is going to be the case. Then the other things that we are going to be investigating over here is, remember, according to that formula that we talk about it, we can differentiate the integral function. So if you want to differentiate the integral function, okay, so this is going to be the case. Also, the thing that we like in calculus is that also you are going to note that this function is nice, it's differentiable. Note that y equal to the ln x is going to be, is an integral function. Okay, is an integral function. Since it's an integral function, then we can differentiate it. And the derivative of this function is going to be what? Remember, this is going to be derivative of the ln x. And this is going to be simply the derivative of the integral function that we have over here. And we already talked about it. If you want to find the derivative of the integral function, so, this is going to be the derivative of antiderivative of a function. So the result would be a function. So this means we drop this integral notation and we replace the t by x. So that gives you a very famous formula. Okay. So that gives us a very famous formula, and this is the main reason that we are looking for this function. This means the derivative of ln x. Okay, derivative of ln x is simply 1 over x. So that will take care of that power of a negative 1 for us. Okay, so this is going to be two observations quickly from this function. So this function is nice, it's differentiable. Okay, the function is going to be differentiable. And then nicely we can find the derivative of this function. I'm going to write it down officially in a minute. But there is any question so far? So as I told you, it's quite different from the way you do it in college algebra or pre-calculus. We're just using this idea of the integral. And that's why we discuss it now. We didn't discuss it at the beginning of the course. So, so far our observation is from the formula abstract. We get replace the x by 1. So ln1 would be equal to the 0 because we did 1, 1. And then the other part is going to be just using the fact that it's differentiable. Since it's differentiable, so the derivative of the function is going to be just, okay, it's the derivative of integral function. So we drop the integral and replace t by x. Okay, so this is going to be one observation. Before going on, there is another observation that we can have. Okay, look at this graph that we did. So as you can see, we have to start from 1. Okay, 1 through the x over here. And that was only the reason that we did. The reason that we did was the fact that the integral was, when we talk about the integral, we go with a smaller number up. So 1 up, 1 up. So if you want to think about the domain of this function, domain of the ln x, so the domain of the ln x would be what? Would be 1 up, which is going to be 1 through the infinity. But if you look at this graph that we get over here, see, according to this definition, I just picked the x to be to the right of the 1. But as you can see, you can have something to the left of the 1 because there are some area over here. The function is not defined at 0. It's going to be defined for, okay, for all, if you like it over here, for x greater than 0. So let's see what we can extend our function. So as you can see, if you pick your x to be here, look at this one. If you pick your x going to be here, means if x is less than 1, of course. Then if you draw the vertical line, and there is going to be an area here. You see, we get this area. So if you want to copy this information that we did, we should be able to define it. Okay, so you should be able to define it in this case, but there is going to be a technical difficulty. What's going to be technical difficulty is, so let's make it official. So we are going to note that, okay, note that if x is going to be less than 1 this time, but never 0, okay, we cannot get the 0 because 1 over t. So if x is going to be between 0 and 1, if you're going to be to the left of 1 over here, okay, to the left of the 1, and I can put it over here so that you can see it again. You see, this is the graph of the 1 over t, and that was the crucial one. Okay, that's a crucial one that we are investigating. So this time we are going to be interested in a point to the left of the 1. Okay, so this is going to be the point, which is going to be a number less than 1. If you pick the less than 1, so this is going to be your x. So as you can see, there is a area. There is going to be area. So this is going to be, there is going to be an area. So this can also be called ln x. Okay, but let's see if it's going to be consistent with your definition. So if you continue here, you see if x is between 0 and 1, then the question is going to be, how are we going to define this integral? You see integral 1 plus 1 to x, 1 over t dt. You see this is going to be what? Okay, so suppose x is equal to the 1/2. If x is going to be equal to the 1/2, you cannot say that integral from 1 to 1/2. We can say that, but you have to modify it. 1 to 1/2. We can do it if it's happened to be 1/2 to 1. But remember, we already talked about it. We talk about the fact that if you switch the limit of integrations, so your integral is going to be opposite of the previous one. So this means if the previous one is a positive number, then the other one would be a negative one. So if we have to find the integral from 1 to 1/2, so what we have to do is we have to switch it. If you want to switch it, so just put a negative sign here. and then you switch. You say x to 1 over t dt. The only thing is this would be a negative number, not a positive number. Okay, so that gives you the advantage that you can extend your function nicely, not only for x greater than 1, as originally is defined, but also you can define it for any number between 0 and 1. So that's very important because that gives you the domain of the ln function. So we can extend that definition, say, oh, this is it. How are we going to find it? This is it, therefore, ln x. Okay, ln x, ln of x, yes, it's defined from 1 to x. Okay, 1 to x, 1 over t dt. But remember, for all positive number x. So quickly, this means the domain of the ln function is going to be 0 and positive infinity. And that's very important fact that we have to consider before moving on. Okay, so that would be official definition of the ln x. So the ln x is a function that's defined only for the positive number. You never be able to define ln of 0, but you can define ln for the positive numbers only. Of course, if you are going to be measuring physics or engineering in future, there are going to be a situation that you may face with the ln of a negative number. If you stay with the real number case, if your system is just accepting only real numbers, in that case, ln of -1, -2 is undefined, like this course. So you never have a negative x here. But in future, if you extend your information to the complex numbers, then we can also define we can define the natural log of negative numbers. But that would be another story. You have to take calculus 1, 2, 3 first, then you come back and you do it. If you take physics, you have a course, they call it mathematics for physics or advanced calculus. Then they define it, okay? So if you see it somewhere, don't be surprised, that would be another story. In this course, using only real numbers. So the ln is going to be, the domain of the ln is going to be positive numbers, okay? You cannot have a negative number as your entry. Any question? So make sure you know the domain because that's going to be very important for you. Now, the point is going to be how we're going to find this other value of the ln. If you want to find it, you have to use your calculator. It depends on the type of calculator that you have. We're just checking the one that I have. Okay. So, in various calculator, so there are going to be different types of the ln that we're going to explain it. But this is the one, ln. So if you want to do, for example, anything and using this calculator, just turn it on. Okay, so if you want to use my calculator over here, so it's going to be ln, for example, if I want to find the ln2, okay, this is going to be ln2. So the ln2 should be, okay, that's going to be ln2, which is equal to the 0.69. So if you have an application problem in this course and you have to find it, this is the way you are going to know you are going to do it. So for example, if you miss it and if you want to find the ln of, for example, let's say -3, remember we talked about it in this course, it's not defined. So that gives you an error. This means that again, negative numbers are not going to be in the domain of the ln function. Okay, so make sure you know it. And if you make a mistake, and if you want to find the ln of, if you want to find the ln of 0, you shouldn't be able to do it because the 0 is not in the domain of the function. Okay, so make sure that when you use the ln, you're just using the positive numbers. So if you pick any other positive number, that should give you the result. You see, if you want to find the ln of 7, for example, ln of 7, this is going to be ln of 7. Okay, so there are a couple of them that we have to use in application problems. And of course, if you continue taking courses, it doesn't matter. You have it in physics quite a lot. Okay, so anytime you have a doubt about it, you just check your calculator to make sure you remember that the entry for the ln function must be positive numbers only. Okay, so this is the way we create this natural log function in calculus. Okay, any question? Now this domain is very important for us, so I just give a couple of examples that we are going to use in this course regarding the domain, and then we continue. So we have a new function, nice. We introduce the function by a natural, as an integral function in calculus, and we end up in the fact that the domain of this function could be 0 and positive infinity. So there are a couple of things that you have to know. Okay, so let's give you a remark, and the remark is going to be regarding these positive and negative numbers. So as you did it in the case of the integral, so this is going to be a remark that would be helpful. We define the ln natural log for the positive numbers. If your number is going to be between 0 and 1, as we did it, okay, if the number is going to be between 0 and 1, look at this one. If you're taking the ln of a number which is bigger than 1, the ln is going to be positive numbers all the time. Okay, it's going to be positive number because of the area under the curve, which is up here. But if you pick any number between 0 and 1, 0 and 1, remember the value of the integral, which is going to be the value of the ln, is always a negative number. Okay, I'll just show you again. You see, if you want to find the ln of a number between 0 and 1, something like 0.5, you see ln of 0.5, that give you a negative number. Okay, because you pick a number which is less than 1. But if you pick a number bigger than 1, okay, if you want to find the ln of 1.5, okay, 1.5, that give you a positive number. Okay, so that's a fact. It's good to know it, to remember it, that the domain is 0 and positive infinity. But if, okay, so that will help you from time to time to know it. So note that. Okay, note that if your function is y equal to the ln x, okay, it's going to be ln x, and then, okay, then the domain of this function is always all positive numbers. And that's going to be the case also, as we talk about it. If your entry is bigger than 1, okay, also ln x is going to be, okay, ln x is going to be negative if your x is, of course, between 0 and 1. Okay, and ln x is greater than equal to the 0 if, okay, if x is greater than equal to 1. Okay, so it depends where you are. So this basically means the range of the, okay, therefore the range of this function, okay, the range of y equal to the ln x, you see you get the negative number and positive number and the 0. So the range of this function is all real numbers. It is going to be all real numbers. Okay, so that's good to know. So far, we just give everything we need to the function. So this is it. If y is equal to the ln x, then the domain of this function, okay, the domain is 0 and positive infinity, and the range of this function going to be all real numbers. Okay, the range is going to be negative infinity and positive infinity. So this means any number you think about it is going to be ln of something. Okay, so this is the basic information that we need to know, that you know that any function, okay, so if you have you know, any function is given to you, you should have information about the domain of it. Now, the way you are going to use it, some functions may be given to you, okay, indirectly, because you want to find critical values of this function, so you need the domain. So I give you a couple of them that we use more often. Okay, that's it. Example, would like you to find the domain of each function. Find the domain of each function. There are a couple of them that we are very much interested in. Okay, so this is the first one, like y equal to the ln, okay, ln of x minus 1. Okay, it's a natural log function, and we know that in case of the natural, you see this is not x, it's x minus 1. You can call it z if you like, ln z. If it's going to be ln z, it's only defined for the positive number. So this is going to be defined if z is the entry is bigger than 0. So the entry x minus 1. So in this case, this is the way you're going to determine the domain. Solution is you have the function y equal to the ln of x minus 1. This function is defined if this entry is going to be greater than 0. So if x minus 1 is going to be greater than 0. And then you move the 1 to the other side so that you have x greater than or equal to 1. So the domain of this function is going to be 1 and positive infinity. Okay, so sometimes you may be given something other than the x. If it's going to be anything other than the x, then you have to modify it. Okay, so this function is defined if the inside is positive. Most of the time, you are going to have ln x in this course, but if you get ln x minus 1, so it's going to be defined on positive infinity. Okay, any questions? This next function is very popular. You are going to see it several times in this course. Okay, there are many applications of this function. So it's going to be y equal to the ln, okay, equal to the ln of x squared plus 3x plus 11. Just repeat it probably, to make sure that we have seen this problem. Okay, you may have seen it before, but we are going to remind you. Okay, so this is going to be, let's check this one. So again, you see, this is not x, something else. You may call it z. It's like ln z. So ln z is defined if z is positive. So you have to check there. This is going to be positive. Okay. So a little bit of algebra you need just to be refreshed. Solution. So we get the function is going to be defined if this inside is always positive. So we say that the function. Okay, the function is defined. Okay, the function is defined when, okay, it's going to be defined when this x squared plus 3x plus 11 is going to be, okay, is going to be positive. That is going to be a situation we're going to have. And now you know that this is a kind of inequality that we usually solve in algebra courses. Okay, so this is going to be the case. So the function is defined when x squared plus 3x plus 11 is greater than 0. But in algebra, what we do, we try to factor it and then check to see. It depends how many solutions we have. Okay, so this is going to be the question. We try to solve this one. X squared plus 3x plus 11 equal to the 0. You see, if you want to factor it, it's not possible because you cannot find two numbers whose product is 11. Okay, whose product is going to be 11 and the sum is going to be 3. So it's not factorable. Probably it doesn't have any solution. But if you want to be more precise, you may have to check it further. So, we check delta discriminant to see if there is any solution. So if you check the a equal to 1, b equal to 3, and c equal to the 11, remember you have to form the delta b square minus 4ac, or just go try to solve it. So I just explain it a little bit more in details so that you remember it. So this is going to be the case. You see 3 squared is 9 minus 44, and this is, of course, is a negative number. You know that when a discriminant in a quadratic equation is negative, so this means your equation has no solution. Okay, so the equation has no solution. Okay, you know that when it has no solution, this means in algebra, we say that the sign of the quadratic equation, when there is no solution, is always the same as the sign of the x squared. Coefficient of the x squared, the coefficient is positive. So this means this is always positive. And if you have any doubt about it, just check one number. You see, from negative infinity to positive infinity. If you check, for example, 0, you see, if you put x equal to 0 in your equation, what are you going to get? 0, 0, 11. 11 is positive. So this means it's always positive, 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 positive. Always means the domain of this function is all real numbers. Okay? So this is a very popular function in calculus, and you're going to see it. It's going to be in your practice quiz, practice test. We like this one because the domain is nice. Domain is nice, and if you want to upgrade any question on the log function, usually refer to this one. Okay, so the quick answer is going to be really, as soon as you brought it here and you feel that you cannot factor it, then you can go for it. You say, oh, this is quadratic function. It's a quadratic expression with no solution. Okay, no solution or no factoring if you like. And the sign is always the sign of the x squared. The sign of the x squared is positive, so this is always positive. Or you can check a number from negative infinity to positive infinity, because you have no solution to partition this one as in algebra. So I just pick one number. It doesn't matter. Any number you like. 0 is the easiest one. And you don't have to explain this for us, okay, when you're doing this actual problem in calculus. But make sure that the domain of this function is all real numbers. Any question? We don't need any complicated one. We need this to make sure that you are ready for it, because this would be given to you. That's a very popular function. This would be given to you and ask you to find apply the first derivative test to this one. So this means you have to differentiate it, find the critical values, then give us a table where the function is going to be increasing, decreasing. So get to know it. For doing all these, you have to give us the domain first. Okay, so it's going to be 1, 2. Any question? Okay, I'll just give you one more. And this function is going to be used, and probably you have seen it, of course, in algebra. So what is this function? This is it. How about the function f of x equal to, or y equal to? F of x equal to the ln of the absolute value of x. Look at this one. It's going to be used in a minute. So what's the domain of this function? Any suggestion? Have you seen this function before? Remember, it's a natural log function. So the natural log is defined if the entry inside is always positive, but you have the absolute value. So when you see the absolute value, you say, oh, I know that the absolute value, it doesn't matter whatever number x is. So the absolute value of x is always positive. So I should have all real numbers as the domain of this function. But there is only one catch. When you say all real numbers, 0 is one of the real numbers. But remember, if you put the 0 here, that gives ln 0. And ln 0 does not exist. Again, if you have anytime you have to doubt about it, you can check you check your calculator. Okay, so f of x equal to the ln of the absolute value of x. This is defined everywhere except for 0. Okay, So the solution is going to be, because you have the absolute value, so we are not going to worry about the positive or negative sign. So the function is defined. The function is defined only when x is not equal to the 0. That's it. So if you like, the domain of this function is going to be all in numbers except 0. So this means this is the number line from negative infinity to positive infinity. And you have to take out the 0. You see, 0 out. So in this case, the domain of this function is going to be negative infinity to 0. Okay, union with 0 and positive infinity. Or simply all real numbers except 0. Okay, or some people, they like to write down all real numbers except 0. Okay, so this notation is more popular, or just write it down in word form, because this is going to be just a one case that we're going to use it. And we want to make sure that you are going to pay attention, okay, to this part. Okay, so this is going to be the case. Any question? So now you know the function that we're going to deal with. In algebra, you stay with the ln function and you do your algebraic operations, but this is calculus. If you haven't seen it, okay, if you need more information, you just read the section. I think it's the 5.1 or 5.2. They talk about it, but we are briefly talking about the nature of the function from calculus point of view, okay? And we are going to be interested in differentiating, integrating, okay? But in the meantime, we give you whatever you need. So we're getting back to the original argument, and that was the idea of the, okay, the idea of the integral function. So we have this theorem about the derivative of the ln function. And this is the only one that we need to know really. So what is going to be the case? There you are, as we talk about it. So we are going to make it official. This natural log function is always differentiable. So if f of x is equal to the ln x, ln natural log, then of course this function is differentiable. Then f is differentiable. Okay, is differentiable, and the derivative of the function f prime of x is equal to the 1 over x. Okay, of course, we know that 1 over x for all, of course, positive x, because the domain of the natural log is all positive numbers. Okay, so it's very easy to operate. Okay, so therefore, there you are. Very easy derivative. The case is going to be derivative of ln x is going to be 1 over x. 1 over x, then x is going to be positive. Okay, so that will give us the result. Okay, any question? Now, of course, we may have to deal with something other than the x. So we bring the chain rule. If, okay, if u, as usual, equal to the u of x is going to be a differentiable function. Is differentiable, means you can find the derivative. Is going to be a differentiable function. Okay, differentiable function of x. So what would happen? Then derivative of ln u. Now it is a composition of two functions. Outside function is ln, inside function is u, like sine u, cosine u. Derivative of ln u, we know that it's going to be 1 over u. But you have to multiply by derivative of the inside, which is u prime. So basically, this is going to be u prime u. Very easy formula and very important one. So derivative of ln u is simply u prime u. This is the two formulas, two famous one that we are going to use to the end of this course. Okay. So this is going to be the case. Any question? So just two things to remember really. The first one is the domain of this function. As we talk about it, the domain is positive numbers because this is the area under the curve. That's it. Okay, this is it. The domain is going to be positive numbers. We talk about it. You cannot find the ln of a negative numbers. If you want to differentiate it, it's going to be just 1 over x, just using that idea of the integral function. And if you have anything other than the x, we're just using the chain rule. ln u, derivative of the outside 1 over u prime, u prime u. Okay, so you get one question on differentiation. It's going to be two questions, but the first one is just finding this derivative on the next quiz and on the final. Okay, and it's usually you have no difficulty in operating with those. Okay, so get the definition, give you all the possibility of integrations. Sorry, on differentiation that we are going to be interested in. Any question? You can add these two to the list of your formulas and bring it to the test. Derivative of ln x 1 over x. Derivative of ln u, u prime u. U prime u is going to be, it's going to be a parenthesis, and u is whatever it's inside that parenthesis. Okay, so we are going to give you those famous examples. They are very, easy and familiar examples. So there you are. These are the possibilities. I would like you to find the, okay, there you are. Find the derivative of each function. Find the derivative, derivative of each function. Derivative of each function. Okay, so the first one is f of x equal to, it's going to be a power of x times ln x. Very easy case. It depends where you are in calculus. It's use x ln x, x squared ln x. Nothing complicated, but since it's a popular and used quite a lot, we want to make sure you know it. So what is this? You see, this is a product of two functions. So the first function is x to the fifth. You see, this is going to be a first function. And the second function is ln x. So we have to apply the product rule. Okay, just remind you that I'm going to use the product rule, and the product rule, remember, this is the product rule. Derivative of the first one times the second one plus derivative of the second one times the first one. S prime times f. That would be your formula. Okay, so what's going to be the result? F prime of x equal to derivative of the first one. You see, you bring the 5 down. So that gives you a derivative of x to the fifth, 5 x to the fourth, times the second function, ln x, plus derivative of the second times the first one. Derivative of the second one, derivative of ln x. Derivative of ln x is 1 over x. That's the derivative of the second. Times it by the first one, times it by the first one, x to the fifth. But you're not done. You have to simplify it. You see, always you can simplify these. That's x to the fifth and the x. You simplify that, give you x to the fourth. So the final answer is f prime of x equal to 5x to the fourth ln x, okay, plus x to the fourth. So that gives you f prime of x, and you're done. Any question? Remember, this is the end of the problem. Some people try to do something to this. You'll never be able to do anything. Some people factor out x to the fourth. Why you factor x to the fourth? It's done. You see, the simplification means make it short. Make it short means remove the parentheses, combine the like terms. There is no parentheses left, so no multiplication. And you cannot combine them together because they are not like terms. Okay, so don't try to do something else. Any question? But some people, they stop here. You're going to lose points. You're not done. You have to simplify it. Okay, so that's going to be easy case one. Okay, any question? Case two that we are going to use. Case two is a kind of quotient function. Again, we are interested in the quotient function that we are going to use in future. Okay, so that quotient function is this one. G of x equal to, the top would be kind of ln x. The bottom one again is going to be power of x. Okay, let's try something like x squared. It's going to be x squared. You want to find the derivative of this function. Of course, you have to use the quotient rule this time. You see, remind yourself that you have to use the quotient rule. Remember the top, bottom, differentiate. Derivative of the top, t prime, times the bottom one, b, minus. Derivative of the bottom one, b prime, times the top, divided by the bottom squared. Okay, derivative of the top times bottom, minus bottom top. Now let's operate. So that is going to be g prime of x equal to g prime of x is equal to derivative of the top, derivative of ln x, remember 1 over x, 1 over x, times it by the bottom, times by the x squared. Okay, that's derivative of the top times bottom, minus the derivative of the bottom times top, derivative of x squared, 2x times top ln x, but divided by the bottom squared. Divided by the bottom square means x squared. Okay, so we operate the formula, but we are not done. We have to simplify it. Okay, the simplification for this one is going to be, you see this x squared and the x. You can simplify 1x, so it's going to be equal to, okay, it's going to be equal to the top would be just x, okay, minus 2x ln x, and the bottom is x squared. If you have a multiple exponent, remember, if you have a multiple exponent, you multiply them together, so that gives x to the 4. So that would be, I just rewrite it. This is going to be the final answer. X minus 2x ln x, but divided by x to the 4. Again, this is the best you can do. You cannot do anything else to this one. And that would be the final answer. Any question? So be prepared for some, a combination of, the product and the natural function, natural log, or the quotient rule. So be prepared for it. Okay, so this is going to be 1, 2. You see, in these two cases, we didn't need to use the chain rule. Now the other type is going to be the chain rule type. So that will take us to the number 3. Okay, 1, 2, 3. In number 3, the function is going to be something like h of x equal to h of x equal to the ln of 3x squared plus x. So this is going to be another case that we have. As you can see, the inside is not x, it's something else. So something else, we call it u. So you remember that you have to find the derivative of ln u. And the formula, you see, the chain rule was u prime u. So if it's going to be ln x, so the derivative simply would be 1 over x. That's going to be ln u, the derivative would be L prime u prime u. So in this case, the solution is going to be, you see, your h prime of x is going to be equal to u prime u prime, derivative of 3x squared plus x. So that gives us 6x plus 1. Okay, divided by 3x squared plus x. So that gives you the final answer. Okay, h prime of x, 6x plus 1 on the top, and 3x plus x. Okay, so again, you cannot simplify it. Don't try anything. You see, some people try to simplify this one, which is not going to be possible. It's simply u prime, derivative of the top divided by the bottom. Okay, any question? The function that I gave you, because we are going to find the derivative of this. You see the one that we talk about it? So suppose you have a y equal to, okay, y equal to the ln of x squared, okay, x squared plus 5 tangent of x. This is going to be the case. Again, you are going to call this one u. So we are going to find the derivative of ln u. Derivative of ln u, which is going to be u prime u. Okay, so we got careful over here. This is it. So solution is going to be y prime is equal to u prime u. U prime is going to be the derivative of the inside. Derivative of x squared is 2x. And it's going to be 5 times the derivative of the tangent. The derivative of a tangent is secant squared. Secant squared of x divided by, okay, divided by u prime u. So that gives x squared plus 5 tangent of x, the final answer. Okay, so we are not going to be interested in anything complicated. Okay, there are some complicated problems in your book, or they deal with it, but you should be able to take care of the one that's going to be used either, in science or, in some other problems that we can try. Okay, so this is almost all the possibilities that we have. Now, there is going to be one more problem for the derivative, and this is the one that we are going to use it later on. Okay, that's the number 4. Do we get the number 5? Any question? So just make sure that all these are, remember the formula, especially for the chain rule type. You see u prime u nicely can be done. And the other part is the one that there is no chain rule involved. But this next one is going to be used when we get to the integrations. So we are going to put it here, and we make a remark at the end. So this is observation, if you like. So that's a number 5. And the function is this one, y equal to the ln of the absolute value of x. We want to differentiate this function. Okay. So that's going to be the case. Okay, now when you want to differentiate this, again, you have the absolute value. Remember, anytime you have absolute value, you cannot do it right away. So you have to break it in 2 parts, because the domain of this function is going to be all real numbers except 0. So you have to break it in 2 parts. The part that x must be positive and the part that x must be negative. Okay, so this is going to be the case. So this is the way we're going to take care of it. So, oh, this function, I cannot do it. I have to rewrite it. So the rewriting would be what? Would be the case that the y is equal to. Okay, that's going to be the case. If x is positive, you drop the absolute value. Of course, you have ln x. So this is going to be the case if x is going to be positive. Okay, but what would happen if x is negative? If x is negative, this would be ln of what? ln of a negative x. Negative x when x is negative. Remember, you cannot use 0 because the ln x is not defined when x is equal to the 0. Okay, so y would be ln x when x positive, and would be ln of negative x when x is negative. Now we differentiate. Remember, when the piecewise defined function, the difficulty was partition point, equality. There is no equal to. So we can easily differentiate it, each part separately. So what's going to be the derivative of this function? Okay, so this is it, y prime. Y prime is what? This is it. Y prime. Derivative of ln x, 1 over x. So that would be 1 over x when x is positive. Okay, now the other part, you see now here, you got to be careful. When you want to get the second one, it's not ln x, it's ln something else. So what you have to do is, you have to consider this one to be u. So you take this one to be u, then you have to apply the chain rule to get this one. Remember, derivative of ln u, derivative of ln u is going to be u prime u. Okay, so this is where you have to pay attention. So we say, oh, derivative of this one is going to be what? U prime. If of negative x would be negative 1. Okay, negative 1 over u, which is a negative x. Okay, when x is negative. But negative would be positive. Okay, this would be equal to the 1 over x. You see what you got over here? So this means the derivative of your function is simply 1 over x. So this means the derivative of, okay, the function is 1 over x. Is 1 over x, of course, when x is not equal to the 0. This conclusion would be something that we are going to use quite a lot later on. So you have to remember this one. I just find it, so when I want to talk about the integral, then you know it. Therefore, derivative of ln of the absolute value of x, it's just the same one, just 1 over x. Okay, it's going to be 1 over x when x is not equal to the 0. So this means it doesn't matter really that whether you have the absolute value or you don't. The formula for the derivative is the same thing. Okay, it's the same for the, if you get ln of the absolute value of u. So you get a u prime u. Okay, so our formula is going to be always the same. You will see the reason when we talk about it later. And you have a couple of problems in your book that they use absolute value when they give you the function. They give you just one of them. So this means you ignore the absolute value. Just find the derivative as you know it. Any question? So you will see how I'm going to use this one when we get to integration. But just for the record, the example, if you be given this, in your book, you have some of them. They ask you if f of x is going to be ln. Okay, ln of the absolute value of x squared plus 5 secant of x, you see, then we want to find the derivative of this function. You see, you want to find the f prime. So ignore the absolute value because I proved it for you. So ignore the absolute value means you call this one u. So the result would be just simply u prime u. So it's equal to u prime, give you 2x plus 5 times secant. The derivative of a secant is secant tan. 5 secant of x, okay, tangent of x, divided by u, which is x squared plus 5 secant of x. And then you're done. Okay, so if you see the absolute value, in the case of the differentiation for the ln, ignore it. Just go ahead and use the formula for the differentiation. Okay, so that's a basic derivative of the function that we are going to have. Okay, I'll give you a break now. We come back and we give you a couple of optimization problem. Remember the maximum, minimum, to see, because we give you two questions on this. This is one of them. It's finding the derivative of the function for us. And the other one is, we give like the one we did before, that you may have to use first derivative or the second derivative to get these true. Okay, so it's almost 11:06. Okay, let's come back at okay 9:20, and then we continue. We stay with the natural log today. So this is differentiation. After those optimization problem, we can go to the integration right away. In your book, they do it separately, but we do all of them at the same time. Okay, so see you then. Okay, so we are going to continue. So these are all we need really for calculus. But there are some property of these functions. From time to time, we may use it from, especially when you want to do the problems in your book. Okay, some algebraic property of the Ln functions. So you are familiar with these type of ideas, but I'm going to list it in case you don't remember it. Okay, and then we continue going to the integrations. Okay, so these are the kind of algebraic property of the Ln function. Sometimes if you know it and if you apply it, make things easier for you to, especially to differentiate the function. So these are the ones that we're going to be interested in. Okay, so this is it. Remark just from algebra. All of them can be proved again, but you already know it. So we are not going to prove anything. So we just recalling this information from algebra. Recall that. The rules that we know, the first one is, this is the one we call it power rule in algebra for the log function. And this will tell you that any power for the log, see if you have ln of x to the r is the power, you can bring the r up in front, r ln x. It's the one that in algebra you refer to as a power rule. Okay, so that would be power rule. You bring the power down, that's the first one. The second one, the natural log of the x1 times x2. One we call it the product rule. If you have any product, you can break it in two parts. It's going to be ln of x1 plus ln of x2. Okay, this is the one that in algebra you call it product rule. Okay, product rule. So the product rule, you just break it. Then you have, we call it quotient rule. Okay, this is going to be ln of x1 over x2. And this is going to be the natural log ln of x1 minus ln of x2. And this is the one that we refer to as a quotient rule. Okay, quotient rule. And the other one that we are going to use, you see in calculus, we talk about the natural log only. And if you have to talk about anything else, okay, any other log, we can use this formula. So this is the fact that if you have if you have the log, the usual log of x at base a, if this is going to be the case, you can change it to the natural log. This we change it to the natural log. It's going to be equal to the ln x, okay, ln a. It's called, change of base, okay, base change formula if you like. Okay, it's going to be base change rule if you like, formula. Okay, so that will help you. If you are going to be given anything other than the natural log, okay, anything other than the natural log, so what we do is we simply change it to the natural log. So this means we don't need any other log other than the natural log. Okay, so this is the last one that we are going to use in this course. Okay, I'm not going to give you anything other than the natural log for the test, but you have some problems in your book, or you may have it in future, so you are going to be ready for it. Okay, so I give a couple of examples to see how we're going to operate these rules in calculus. Okay, for example, of course, we can just use it in order to differentiate. So we would like to find the derivative of each function. Find the derivative. Okay, the derivative of each function. Have a couple of them again in your assignments. So, for example, the first one is this one. F of x equal to ln of the cube root of the x squared plus 1. You see, you want to differentiate this. You know that you can call this one u and just use the formula ln u equal to du prime u, and you'll be able to find it, no problem. Or you can use these properties to simplify it a little bit. So if you want to simplify it, you know that we don't like the radical, so we switch the radical first. So this is going to be a solution if you want to do this simplification. So this is it, f of x. We rewrite it, it's going to be ln of the x squared plus 1 to the 1/3. Then according to the power rule, you can bring the power down. So we can write this one as 1/3 of the ln of x squared plus 1, you see? Now this is very easy to handle because we are going to call this one u as simply derivative of ln u. We know that this is going to be u prime u. Okay, so it makes things easier for you to differentiate. So f prime of x would be, we keep the 1/3 as is, 1/3 u prime u prime derivative of x squared plus 1, which is going to be a 2x divided by x squared plus 1. That's it. No, you cannot simplify it. This is going to be just a 2x, if you like, 3 times x squared plus 1. We accept it. You can multiply it if you like, but otherwise, that would be the end of the problem. Okay, so as you can see, it's easier when you know this one. Otherwise, you can stay with that and just apply the chain rule here to get it through. Okay, so this will help you if you see this type of function. Any question? You have one more in your book. You say this is, look at this one. If you don't use this idea, then it would be a difficult problem to handle. So what's going to be this? Again, if you look at this, the function is g of x equal to the ln, but the fifth root. The fifth root of what? 2x minus 1 divided by x cubed plus 1. Again, you see it's very complicated function to handle if you want to do it as is. But before differentiating, you can simplify it. Again, the fifth root, we change it, we remove the radical, everything would be to the power of a fifth. Then you can bring a fifth down. Then this would be ln of a 2x minus 1 over x cubed plus 1. Then you can apply the quotient rule. See, at the end, you write it down. Everything would be end up with the ln u dq. Okay, so again, it's nice to know. Solution. Rewrite it first. G of x is equal to the ln of, ln of 2x minus 1 over x cubed plus 1, everything to a fifth. So you bring a fifth down, a fifth, and that would be ln of 2x minus 1 over x cubed plus 1. You see? Now you have a quotient of two functions. So we can apply the quotient rule to simplify. You see the quotient rule? So this is going to be the case. So your g of x would be equal to, is going to be equal to a fifth, ln of, you can apply, a bracket here if you like. So that give ln of the top, ln of 2x minus 1, you see minus, ln of x cubed plus 1. This is going to be the case. Okay, now it's easy to differentiate. Easy to differentiate because you can call this one u. This would be ln u, and this would be ln u2. Okay, so g prime of x is going to be equal to, a fifth, okay, times it by u prime u prime derivative of 2x minus 1, which is going to be 2 over 2x minus 1, minus u prime 3x squared divided by x cubed plus 1. You see, that would be the derivative of the function. We can simplify it if you like, but we are interested in the derivative only. Okay, again, these are going to be the one that you have in your book. So, that give you the chance to check them just using these properties. Any question? So in your book, you have a set of problems. They say, apply the property of the natural log to differentiate. The property, they mean the following to get these numbers. Okay, that's 1, 2, and this is the third one that we're going to be interested in. Okay, the third one is the one that you may be given a log at any other base. There is a formula for it, but I don't want to give it the formula. Okay, so number 3 this is the one that we need or we like from this section, this in remark. You want to differentiate this function. Okay, and the function is f of x equal to, it's going to be f of x equal to the log. Okay, it's going to be equal to the log of x squared minus 3x, for example, with the base 5. You see, it's not a natural log, it's ordinary log, if you like. So what we can do is we can change it. We can rewrite it into the natural log, and then you go for it. So this is the way we change it. Solution. Okay, that change of base or the base change formula. This is it. So what I'm going to do is, it's going to be f of x equal to, you change it. It's going to be a quotient on the top, ln of x squared minus 3x divided by ln of 5, you see? So quickly we change it. We change it to the ln. ln of 5 is a number. You can use your calculator and find it, or you can keep it and find it at the end. So we can rewrite it as, you see, rewrite as 1 over ln 5, which is a number, then the ln of x squared minus 3x. That's it. Now differentiate. This is ln u, and this is just a number. So f prime of x is going to be equal to, okay, f prime of x equal to the differentiate 1 over ln 5 is a number. Now u prime would be 2x minus 3, and the u is x squared minus 3x, and you're done. That's why in calculus, they work with the ln function all the time, because otherwise you have to carry this, ln 5 all the time. So it's the same as the one that you did before. You see, it's the u prime 2x minus 3 and the u. But because of this, okay, the base is going to be 1 over ln 5. So if you like to memorize the formula that I don't suggest, you can, this is it. If you want, you can change all the formulas that you did before. You see, if you want to find the log of x at base a, it's going to be what? It's going to be 1 over ln a, then derivative of ln x, 1 over x. You see? If you want to find the log of u at base a, it's going to be the same thing, 1 over ln a, but u prime u. You see, you have to carry this base all the time. So that's why in calculus, we're just dealing with the ln x rather than anything else. Okay, but I'm not going to give you any of these on the test. But you want to do your problems in your book, so distribute it. My suggestion is just change the base, ln of whatever it is, or the ln5, the base. This is just a number. You can find it by your calculator. You're just applying the ln function. Okay, so that's why we are going to be interested in ln function only, rather than working with the with the others. Okay, any question? So this is the derivative of the natural log. But of course, anytime you see the derivative, you must see the application of the derivative. What's the application of derivative? You know, we can review everything we did before. Talk about, the tangent line. But we are going to be interested in optimization problem. Optimization problem means we are going to give you one problem and we ask you to find the maximum or the minimum. So you may have to apply the first derivative test or the second derivative test. Okay, so this is the way on the final, we have to give you one question on the first derivative and one question on the second derivative. We're going to give you those questions, but the functions are going to be natural log or exponential function. Okay, so this is the way we do it. You have the final review. I will modify it and I repost it so you can have a look at those. So this is going to be your second question on the natural log. Okay, I told you 6 questions on your quiz, which is going to be repeated on the final. So the first one was just finding the derivative of the function. We did it. And now this is going to be a kind of the second one. So we want you to check for us. Okay, so that would be a good, this optimization problem, if you like. Okay, finding the maximum and the minimum of these functions. Of course, the natural log. Okay, so pay attention. They are easy problem, but there are some algebra involved. Just make sure you know it. So these are going to be a kind of optimization problem. Just finding the maximum and the minimum, if you like. In the application problem, it's going to be optimization. So I would like you to find one question for this quiz and one on the final. Find all relative. Okay, relative extrema, relative maximum or relative minimum. Relative extrema of each function. They are very popular function, familiar, not difficult to handle. Okay, so we just want to make sure you know the idea. And these are the ones that you are going to use in future. Okay, so let's start with the first one. So the first one, the function is this one, f of x equal to, sub f of x equal to the 2x ln x. This is the function. So we want to find the relative maximum and the relative minimum of this function. You know what to do as we did it before. You have to start with the domain of the function. That's a natural log function. Natural log function, the domain are positive numbers. That's the first one. Then you differentiate it. You let the derivative to be equal to the 0 to find your critical points. Then you drop back the critical point, plug in into the function to find the value of the function. That value of going to be maximum value or a minimum value. Then you have to test it. So you have two possibilities or two methods to apply. First derivative test or the second derivative test. For the first derivative test, you know that you need a chart or a prime to find out where the function can be increasing, decreasing. And the first or second derivative, you have to use the f double prime. So this is going to be your choice. Okay, so there you are. Let's check. So it's not going to be a complicated function because we want to make sure that you are able to handle the equation. So domain first, and this is the step that you have to take on the test. Domain, it's ln x. Domain is positive numbers. So step 1, domain, positive numbers. So that's done. Step 2, differentiate. F prime. In this case, you have to apply the product rule. Derivative of the first times second, you say that's the first, and this is going to be the second. So derivative of the first function times the second function plus derivative of the second function times the first function. Derivative of the first function, derivative of 2x, of course, going to be 2. 2 times ln x. That's the first second plus second first. Derivative of ln x, derivative of ln x is 1 over x times the first function, which is a 2x. But remember, you can simplify. You simplify the x and the x. So the conclusion is going to be, this is it. So your f prime of x is equal to the 2 times ln x, okay, plus 2. Okay, so this is going to be the derivative of your function. So you let it equal to the 0 to get the critical points. That's where you have to use the derivative of algebra. It's going to be 2 ln x plus 2 equal to the 0. You know from algebra that if you want to solve this equation, you have to isolate ln x first. So it's going to be 2 ln x equal to the negative 2. You divide by 2 to get the ln x. So ln x would be negative 2 over 2, which is a negative 1. So ln x is equal to the negative 1. Now we have to switch to get the x. We know that the ln x is from algebra again, it's a log of x at base e equal to the negative 1. So x would be e to the negative 1. Just using the inverse function, if you remember it from algebra. Okay, e equal to the negative 1 or just 1 over e. So x is equal to the 1 over e. E is going to be what? E is going to be your critical number. Okay, so the CV is 1 over e. You can stay with the e at this level, or you can use your calculator. It doesn't matter which one, wherever you decide. Okay, we accept it. We want to use the calculator, and this is in my different calculator. The e function would be given to you. I don't have even those easy calculator. The cheap one would give you the result. I don't have it now, but this is it. So check your calculator, make sure you identify where these are going to be. Okay, this is where we get the e. Okay, so what I'm going to do is this is going to be 1 divided by e. Okay, that's it. E to the power 1, if you like. So the result is going to be this one. If you don't want to use or write the e. Okay, 3.67. You can estimate into the 3.7 that we accepted, or just you don't need it at the moment. You can keep it as is. But if you want to find it, that would be the case. Okay, but the e would be fine. But you have to drop it back into the function, then you have to find it for us. Okay, so drop it back to the function to find the, okay, because this is the value of the function you are going to be interested in for finding the max and the mean. So what's going to be f of 1 over e? Again, if you use decimal number here, go to calculator right away, or just do it at the end. It's a 2x, 2 times 1 over e, times it by ln of 1 over e. So that's going to be the case. If you want to use your calculator, you can do it. Or if you know a little bit from algebra, you can do this. You see, we write it as, that's a 2 over e. We write ln of 1 over e as e to the negative 1. You bring the negative 1 down, 2 over e ln e. ln e with your calculator is 1. Okay, this is going to be for this calculator ln of e. Okay, that can be error. It's going to be, I'm sorry. So it's, it's popular. That's going to be ln e is 1, of course. If you want to get it, just try it again. Okay, so this is going to be the case. This calculator is a little bit of, okay, it's equal to 1. You see, it's equal to 1. So this is it. That give you -2 over e times 1. So f of 1 over e is equal to the -2 over e. Okay, this is one choice. The other choice is calculator all over the places. Okay, so the calculator over here is x equal to the, remember, I just do it for the other methods as well. So we check the 1 divided by e. Let's show you different part. See, that was 1 over e, which is 3 point, let's say 3.7. So the other option is you write this x as 0.37. Then if you stay with that one, so you have to find the f of 0.37. Just put it into the function, so that give you 2 times 0.37, okay, times ln of 0.37. Okay, you can do all of this with your calculator to get, to get the answer. So it depends which one do you prepare, okay, for this problem. But we usually give you something that's going to be straightforward, 0.37, then you multiply by the ln, okay, the ln of 0.37. Okay, if you multiply all these numbers together, so that gives a negative 0.357. Okay, negative. It's going to be equal to the negative 0.3736, if you like, 736. You see that give you the 1, and if you check this one, that should give you the same answer. You see, if you divide the 2 by e, divide the 2 by e, that give you, I'm sorry, that was 2 divided by, I'm probably made a mistake, check it again. It's going to be 2 divided by, that's a -2 over e. We just do it. So that's going to be 2. I just want to make sure that the answer is going to be the same thing. Okay. So if we do this one, you see that's 1. You get exactly the same solution. Negative 0.736. So that gives you negative 0.376. Okay, just make sure that use the method that you're going to be familiar with and be able to find it for us. Okay, just use your calculator to get this number. Sometimes we give you something nice, but you have this in your book. Okay, so what we did, this is the candidate, but you have to tell us whether this is a maximum or a minimum. You have 2 choices. So you're not done, you have to test it. So testing. Testing, second or the first. Look at the f prime. F prime of x is simply 2 ln x plus 2. So the second derivative test is easier. Second derivative test. Because you simply differentiate it and check the concavity. Remember, f double prime of x would be 2 is a number, derivative of ln x is 1 over x, it's going to be 2 over x. and the 2 is derivative is 0. But remember, x is positive, so 2 over x is always positive. Is concavity. F double prime positive means graph is curving up, so you are going to have a minimum. So f of 0.37, which is equal to the negative 0.736, is a relative minimum. Is a relative, okay, relative mean. This is in fact absolute minimum because you don't have anything else, to talk about it. You have only one critical number and you end up with a minimum. Okay, so decide about the red one that I did, the calculator. Some people like calculator and they do it right away. We don't mind. You may have to apply it, but you must make sure you test it. So you test it to show us whether this is going to be a minimum or a maximum. Second derivative test is the easy test to apply, because with the second derivative over here, the ln would disappear. We get 2 over x. 2 over x is positive. Remember, it's a concavity. Positive means the graph is curving upward. If the graph curving upward, you get a minimum. So in this case, you have a relative minimum. That's in fact, it's going to be absolute minimum. Okay, so that's the case one. Any question? So these are the type of problems that you may apply in science, in your discipline, really. That's why we give you the one in your book are very easy. There's just a couple of them, but we give you those. There are 3 main ones for this group. Okay, that's the first one. Let's check another one. The other one is this group of the problem, but make sure you test it. Okay, so what's going to be the next one? The same question, but for this function. The function is what? F of x equal to the x squared minus 8 ln x. It's a very popular case. You have various format of this problem. Okay, again, you want to check finding the maximum and the minimum of this function. So we have to start with the domain of the function. Domain is important for us. This is just a polynomial, nothing to worry about. And we have to worry about this one, ln x. Since it's ln x is defined for the positive numbers only. Okay, so again, solution. Domain first. Positive numbers, 0 and positive infinity. Okay, that's going to be the case. So differentiate carefully. F prime of x equal to f of x squared, simply 2x, minus 8 times ln x. 8 is a number. You don't have to use the product rule. So it's going minus 8 times the derivative of ln x. Derivative of ln x is 1 over x. So it's going to be times 1 over x. There is nothing to be simplified, but we can rewrite this one as f prime of x equal to the 2x minus 8 over x. This is going to be your f prime. Any question? Now we have to let it equal to the 0. Okay, let it equal to the 0 to get the to find out what is going to be the critical values. So f prime of x equal to the 0. So this means 2x minus 8 over x equal to the 0. You have to solve this equation, but we have a denominator here. Remember, you have 2 choices. One choice is multiply both sides by x. The second choice is when it's 2 terms, move one of them to the other side, use cross multiplication. So we can do either one. So I like the moving to the other side. It's going to be 2x equal to, and that would be 8 over x You cross multiply. If you cross multiply, I'll give 2x times x would be 2x squared, which is equal to the 8. So we divide both sides by 2. So that gives x squared equal to the 4. And you take the square root. So in that case, you arrive at the fact that x is equal to the positive negative 2. But remember, domain is positive numbers only. So you cannot use x equal to negative 2. Remind yourself that, oh, but x is positive. Okay, so you have only one solution, x equal to 2. Okay, so the critical value is going to be only 2. Any question? So that's critical value, the candidate. You have to drop it back into the function and then test it. Okay, drop it back into the function. Then you test it. So that gives you f of 2, which is equal to the 2 squared minus 8 ln 2. 2 squared would be 4 minus 8 ln 2. You have to use your calculator, give us this number. Okay, again, this is the calculator. And this is going to be 4. Okay, and that's it. Figure out this. So it's going to be 4 minus 8. That's going to be 8, and natural log, ln, depends on your calculator that you use. You have to identify the natural log, okay, ln 2. So, oops, get the error. This is 4 minus 4 minus, and that was 8 ln 2. So what is going to be the result? Yeah, that's it. So negative 1.5 or 1.54. So it's going to be negative 1.54, for example, almost. Okay, so this is going to be, because the ln2 is just something like 0.69, so it's going to be 0.7. So that makes sense. So f of 2 is equal to the negative 1.54. You have to find it. Remember, on the test, we cannot accept this as your final answer. You have to use your calculator. Okay, so that's the candidate. Any question? So this is the candidate. You have to tell us whether this is a maximum or a minimum. So we need testing. So bring the f of x and decide f prime of x. You see, this is your f prime. Test first or second. If you move this one up, you see now the second derivative test is much easier again. Because with the second derivative, we just differentiate it twice. So that's a f prime, so we get a f double prime. F double prime, derivative of 2x would be 2. Differential of here, negative 8 times negative 8 would be a positive. You see it's going to be plus 8x to the negative 2. So you rewrite it, 2 plus 8 over x squared. As you can see, everything is positive. F double prime positive. This is concavity. So positive means up, curving up. So this is minimum. Okay, so f of 2 equal to negative 1.54 is going to be a relative minimum. Relative, okay, it's going to be relative mean. It's going to be relative mean. This is, in fact, again, absolute minimum, because you don't have anything else. You see, you have only one critical number, and on that critical number, you have a minimum. So this must be absolute minimum. Any question? So this is a very popular problem. A variation of this one is in your book. And they like it because it's easy to handle. Okay, the definition. But remember, make sure you put the domain first. Domain, set up positive numbers. Set up positive numbers, and then you need it. Because when we get to this equation, you see positive -2. You know that. You cannot use the -2. Because if you drop it back into the function, that gives ln of -2. ln of -2 doesn't make sense. It's anytime you have any doubt about it, just use your calculator to see if that's going to be the case. Okay, any question? So that is the second case. There is one famous one with the quotient function. I should give you that one too. Okay, so that give you one of them on this quiz and one on the final. So what's going to be this case? This case again is popular in various applications. ln x over x squared. Okay, various powers of x. Okay, so this is the function. And you want to check what is going to be relative maximum, relative minimum of this function. Again, we start with the domain. Again, the domain is clear. This is ln x. Since you have the ln x, so the domain of this function is going to be set of positive numbers only, okay? So solution. Again, we start with the domain of the function. Remember, for all of these, you have to find the domain first. That's domain. Then we have to differentiate it. For this one, you have to use the quotient rule. If top the top times bottom, bottom top. So f prime equal to lift off the top, lift of ln x is simply 1 over x, 1 over x, times the derivative of the bottom one, times x. Okay, that's lift off the top times bottom, minus lift off the bottom times top, lift off the bottom, lift of x is 1 times top. So 1 times ln x divided by the bottom is squared, x squared. Okay, so these two would cancel out. So f prime of x is going to be equal to the top x and x would cancel out to get the 1 minus ln x divided by the x squared. So that's going to be your f prime. Any question? Let it equal to 0 to get the critical value. F prime of x equal to the 0. That's the quotient. Okay, you know that when we have a quotient, a fraction is 0 if only the top is 0. So you have to let the top to because of 1 minus ln x equal to the 0. So you have ln x. Again, you have to isolate it. You move it to the other side. That gives ln x equal to 1. Again, use the fact that ln x is log of x at base e equal to 1. So x would be e to the 1, which is e. And you know it from algebra that ln of e is 1. So that gives x equal to the e. Okay, x equal to the e. So your critical value is going to be e. You can keep the e, or you can use your calculator. You don't need it, use calculator when you substitute. Any question? So that's critical value. You have to drop it back to find the candidate and then test it. So it's going to be f of e, which is equal to the ln e over e. The ln e is 1, and you can use it, use your calculator if you like. It's going to be 1 over e. Or you can use calculator, find it, but you don't need it. You can keep it as is. So that would be the candidate for a maximum or a minimum. Any question? Again, if you don't like the E, just use your calculator, get this number. But the question is going to be, what is this? Is it a maximum or a minimum? So we have to test it. Testing, bring the F prime. This is going to be your F prime. 1 minus ln x over x squared. So which tests are going to use? I use the second derivative for the other problems. But this one, I'm not going to use the second derivative. We can use it, but I'm going to use the first derivative test, because if I want to differentiate again, it's quite a lot to apply. Derivative of the top times bottom, bottom, top. So what I'm going to do is, I'm going to use the first derivative test for this one. Okay, first derivative test. Remember, for the first derivative test, you need a chart. You have to find out where f prime is positive or negative. Remember, up, down, down, up. So we need a chart. Chart. X, domain of the function, 0 and positive infinity. Okay, f prime. F prime of x. And then we get the f of x. Remember, we put the critical value here. Critical value is E. E is about, about 2 point. This is about 2.7, 2.73. Can check it with your calculator. So f of 1 over E is just 1 over E. So the derivative is 0 here. So you have to check the sign of the derivative in this portion. 1, 2. To find out whether the function will be increasing or decreasing. Okay, the way we can do it is just picking some numbers. Pick a number, substitute here, you have to use your calculator to find out whether it's going to be a positive or negative. You see the bottom one is always positive. So the bottom one is always positive, so you don't have to worry about this one. So you have to check a number in 1 minus ln x. Okay, and that can be done with your calculator. For example, you can pick the number 2 here. So if you go to your calculator and find what is 1 minus ln 2, so that gives 1 minus ln 2 is 0.69. So that would be a positive number. It's going to be 0.31. It's positive. Since positive, the derivative is positive here, and your function is increasing. Any question? So you have to, you have to test number for this one because you don't know the ln. Then you have to pick a number here. Again, you can pick number 3. And you put the 3 in the top because the bottom is positive. So you check where is going to be 1 minus ln 3 now. 1 minus ln 3. Then you can check it with your calculator, but it's going to be 1 minus ln 3 is 1.09. And the difference is going to be negative 0.9. It's negative. So negative means that this is negative. And the function is going to be decreasing. Up, down, maximum. You see? So you realize that f of e equal to the 1 over e is a relative. Okay, it's going to be a relative maximum. In fact, again, it's absolute maximum because you don't have anything else, to talk about it. So it's a very typical problem that just want you to see. For the other one, I tested with the second derivative test. But this one, because of that, the quotient function and the fact that you don't need the bottom, because the bottom is always positive. Remember, it's derivative of the top times bottom minus bottom top, divided by the bottom is squared. So the bottom root is squared, so that's going to be the case. So we're just checking the top one. Okay, checking the top one, easily two numbers. Your critical value is E is 2.773. So just two numbers here to check. I checked the 2 and the 3. You can pick any other you like. And you drop it into the top. 1 minus ln2 with your calculator give you a positive number. So this positive, the function is going to be increasing. Over here, I picked the number 3. So the number 3, this is going to be decreasing. Okay, decreasing. So up, down, I get the maximum over here, and then we're done. Okay, that's the kind of optimization problems that you are going to have for these type of function. And there is another one, then you have it in your practice one, then we talk about it. Okay, so we spend a little bit more time other than the one that it's in your book really. They somehow ignore these type of problem quickly, but in future, this is the only type of problems you need, the optimization problems. Okay, that would be enough for today. There is a case with the integration of the ln function. We do the integration tomorrow. So that's a 5.1. Read it carefully. Okay, of course you have your test to take, but read it carefully so far. Differentiation, that's it. Differentiation to be able to differentiate it, and then to be able to take care of one of these problems. And we're going to test it on quiz 4. And so 2 questions so far from this on this next quiz and as text. The integrations are quite interesting. I don't want to push it for today, give you a little bit more time to think about it. But tomorrow we do the integrations, and then we introduce the second function, exponential function. Okay, that would be also interesting. Okay, that's it. Have a good one. Any question? So make sure you get your test, and then we continue tomorrow. Bye-bye.